Did you know that everything is made of particles? You, me, even light. All particles. Sometimes particles can collide and form new particles. Now that's a particle collision.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Everything you see is made of particles, and even some stuff you can't see. So far, scientists have found 17 different types of particles that make up everything. These particles are organized into the Standard Model, a roadmap for all the particles that make up everything. The outer ring of the Standard Model is made up of fermions, which are composed of quarks and leptons. On the top here are quarks. Quarks are responsible for making up protons and neutrons as well as other things. Protons or neutrons are in the center of every element in the world. Every element!
The bottom half is made up of leptons. One lepton you may have heard of is the electron. The electron is the tiny particle responsible for chemical reactions. Some leptons are charged, while others are neutral, and these are called neutrinos.
The Standard Model has many layers, just like this orange.
In the next layer, after the fermions, are the force carrier particles, called bosons. These bosons are like messages exchanged between other particles, and each force carrier has its own secret language.
Bonjour, je m'appelle W boson. Hola.
Only particles that know that language can respond.
Habla español? Je ne peux pas parler français.
There are 4 force carrier particles in the Standard Model: photons, gluons, and W and Z bosons.
Photons are the force carriers for the electromagnetic force. This means they interact with anything that has a charge.
Gluons interact with a strong force.
And they also behave just like springs. The further away two particles are, the stronger the interaction between them, just like in this rubber band.
W and Z bosons interact with the weak force, but only in a short range because they are massive.
In the very middle of the Standard Model is the great and mighty Higgs boson. The Higgs boson is the reason why your books in your backpack are heavy and you can't pick up your house, because the Higgs gives mass to all particles. The Higgs field is everywhere, but some particles like quarks interact with the field more than other particles like photons. This is why quarks have mass, but photons don't.
The Higgs was only discovered in 2012. That's 6 years ago, younger than all of you. But even though we only found it 6 years ago, scientists have known about the Higgs for a long, long, long time. But how? Because particles have mass, and there must have been something to give particles that mass. Now, how did scientists actually find it? Once upon a time, in a faraway land of watches and chocolate, scientists built an underground tunnel 16 miles around. But this is no ordinary tunnel. It is a tunnel for particles. In this tunnel, scientists make particles go around and around and around until they're going super fast and have a lot of energy. And then boom, they collide. And when they collide, even more particles are produced. To find the Higgs, scientists made protons go around the tunnel super duper fast. And when those protons finally ran into each other, one of the new particles they produced was a Higgs boson. This sounds easy, just make the protons hit each other. But actually, the Higgs is only formed 1 out of every 10 billion times that the protons collide. That's 10,000 times less likely than you getting struck by lightning or dying in a plane crash.
Finding the Higgs was a team effort by scientists from all over the world, working on different experiments. But even though they found the Higgs, scientists are still working at CERN to learn more about our world. Let's see what they're working on. Some of the biggest experiments still being done at CERN are ATLAS, CMS, and LHCb. What are those?
ATLAS is an experiment at the LHC that helped to discover the Higgs. It uses 6 different detectors to find the new particles that are formed when particles collide, and is the largest particle detector ever built. The largest ever built! Over 3,000 scientists work on ATLAS. Beyond the Higgs, it also searches for extra dimensions and particles that can make up dark matter. Ooh. CMS also looks for these things, but uses different ways of experimenting and detecting.
LHCb is looking for the differences between matter and antimatter. While everything we know is made of matter, there is also antimatter with particles of opposite charge that mirror matter particles.
Well, that's our show. Particle collisions can be pretty fun. So next time you're in Switzerland, be sure to stop by CERN.
Produced in association with the National Science Foundation.
Bill, 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 Bill. Bill.